Basically, today we're going to be learning about modular arithmetic, which is very related to division. So, for example, you probably can solve a problem like this. So, in the chat, answer this question. Francine bought 63 Nutcracker tickets to share with her friends. If she only has 5 friends and wants to give each of them an equal amount, how many tickets will she have left over? So, in the chat. Okay, yeah, as a lot of you are saying in the chat, it's 3 tickets. The way you did this is you probably first divided by 5 and then you found the remainder, right? Or like you had a shortcut probably, but like that's the actual process that went through your head. You did the division and then you found the remainder. And that is what modular arithmetic is. So we will do 2 more examples like this. So Santa is feeding his 9 reindeer. Each of the reindeer will get the same amount of carrots and Rudolph will get the extra. If Santa has 68 carrots, how many does Rudolph eat? Okay, so there are a variety of answers. So it's 12 carrots. So we have Rudolph, we have that Santa is feeding his 9 reindeer. Each of the reindeer get the same amount of carrots and Rudolph gets the extra, right? So every single reindeer, first we divide it, right? And we get 9. We get 9 reindeer. Right, so 68 divided by 9 is equal to 6, right? Or sorry, no, it's 7. Sorry, 68 divided by 9 is 7, right? And the remainder would be 5. So Rudolph would not only get those 7 carrots that each of the reindeers get, but he would also get those 5 extra because Rudolph also gets the extra, right? So 7 plus 5 is 12. So you would also have to do more complex stuff like that. And then our last example problem. So there are 87 elves and 6 tasks for them to do. If Santa assigns each elf to a task randomly, so there are an even amount of elves at each task, how many elves will not have a task to do? Okay, so yeah, I am seeing some answers. So yes, the answer would be 3. If we have 87 elves and we have 6 tasks for them to do, what we'd want to, and we want to divide them equally, we would do 87 divided by 6 and then find the remainder, right? So we would do 87 divided by 6 is equal to 14, right? And then we would have the remainder is equal to 3, right? Because 14 times 6 is equal to 84. So we would have the amount of elves that don't have a task is 3 elves. So 3 will be dropped. So this, what you just did is modular arithmetic. So modular arithmetic is a system for integers where we consider the remainder rather than the actual number that we get in division, right? So a number wraps around, so a given fixed quantity, which is known as the modulus, to leave a remainder. So for example, in 87 mod 6, right? What this means is we have 87 as a number that would be divided. And we have 6 as the number that divides. And then whatever it is equal to is whatever the remainder would be, right? So we don't care about when we do 87 divided by 6, it equals blah, 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 right? It equals 14, remainder 3, but we don't care about that 14. We only care about the 3, right? So the number that we have after the mod is called the modulus, and it is the number that would divide in a typical math division equation, right? So also the way we would read this is 87 mod 6 is equal to 3, or 87 modulo 6 is equal to 3. And this is just the modulus function, which is just the remainder. So think of a clock. So the time it'll go from so the time will go from 1 to 12, but when you hit the hour that's after 12, it just restarts again and again. That's like if we were doing something modulo 12, a clock would be representing that, because you aren't actually going above, right? You can't have a remainder that's greater than the number you're dividing by. You can only have a remainder that is less than the number you're dividing by. So always remember that. So modulo will always be less than the modulus. So Mrs. Claus just finished, okay. So Mrs. Claus just finished baking gingerbread cookies and is giving them to random kids in the library. There are 97 kids and 18 cookies. Which number is the modulus in this example? So remember, in a typical like equation, the modulus would be the number that divides, right? So if we were thinking about this as division and then thinking about it as modulus afterwards, right, it would be 18, right? Because when we're thinking about this, what we're trying to do is find the remainder when they're we would be doing 97 divided by 18 if we were trying to look at this, and then seeing whatever's left over would be the modulus. Right, so 18 is the modulus. So, okay, just to solve this question, you know, for kicks. So 97 cookies. So if they're okay, if if there are an equal amount of kids per cookie, how many kids will not be assigned to a cookie at all? Okay, yeah, I am seeing some answers. So yes, it would be 7, because we would do 97 divided by 18, and we would see that that is 5. And then we would, and 5 times 18 is 90, right? So we, okay, we do 97 divided by 18, we see that's 5, remainder 7. So that means that there would be 7 kids not assigned to a cookie. Okay, Santa is filling stockings at a house with 3 kids who get an equal amount of candy. Santa has 43 pieces of candy and wants to know how many he will have left over. Write the expression that represents this scenario. So remember how earlier we had like 97 mod 18 is equal to 7, right? So write in the chat like a modulo or a mod, like an equation with modulo in it that would express this scenario. Okay, yeah, I am seeing a lot of answers. So yes, it would be 43 mod 3 is equal to 1. So the first number is like whatever number we are dividing by, essentially, if we were to think of it as a division equation. And then the second number is the number we would divide that by. And then that is equal to the remainder. So 43 mod 3 is equal to 1. So yeah. So good job. So what is 31 mod 4? Yes, 31 mod 4 is equal to 3. So when we find the remainder of 31 divided by 4, we'd see 31 divided by 4 is 7, remainder 3. So it is 3. What is 49 mod 5? Yes, I am seeing a lot of answers. It is 4. So again, 49 divided by 5 would be equal to 9 remainder 4. So 4 is equal to 49 mod 5. And then finally, what is 12 mod 13? Okay, so a couple of you said 1 and someone said 12. So it's actually 12. What a lot of you are doing is in your head, you're like the greater number must be the one that's being like divided, that we're trying to find what like the remainder of when divided by the other number. So in your head, you're just switching the numbers, even though that's not what the question is. If it were 13 mod 12, then you would be correct. It would be 1. However, it's 12 mod 13. So what would the remainder be when we're dividing 12 by 13? It would be 12. So yeah, good job to the person who got 12. So it would be 12, not 1. And that's often an easy mistake to make if you're thinking about it. If like you're in a math competition and you're just like under pressure or something, right? It can be easy to just mess it up, or like even like normally it's easy to mess it up. So just remember, the bigger number doesn't always have to come first. What comes first is the number that we are dividing. So hopefully that helps. So ways to represent mod or modulo. So a modulus on a number line. So we if we were trying to think about 5 mod 2, we could start at 0 and then restart the counting every time we're 1 less than the modulus. So for example, here, if we were trying to do 5 mod 2 on a number line, so we know we could go 2, and then we could go another multiple of 2, and then we're 1 less than that 5, right? So that would mean that we'd have to just start our counting from there, and we could do 0 is the modulo here, and then 1 is the modulo here. So it can be easy to find like the multiple that is right below the multiple of the modulus that is right below the number that the first number, right? And it's easy to do that and then just subtract. So that could be a way you potentially would like to do it for other numbers. And it can be helpful in some cases, for example, when we're using negative numbers, but we'll get to that in a minute. So when we have this symbol, like the equal sign with 3 lines, that's congruence. That is the symbol for congruence, and it means identical to. So 7 is identical to 3 mod 2 would mean that if we were doing 7 mod 2, that is equal to 3 mod 2. And it might look confusing from here because you're thinking 7 is not equal to 3 mod 2. There's no way that could be possible, but that's not what it's saying. It's saying that these two numbers, if we were to perform this, if we were to perform sorry, I'm blinking out. If we were to perform the of mod 2 on both of these numbers, we would get the same result, and that result would be equal to each other. So make sure you're reading it like that rather than reading it as 7 is equal to 3 mod 2, because that is incorrect, because that's not what it's saying, right? Sorry for saying okay. So basically it says that 3 and 7 have the same remainder when divided by 2. So showing multiples of the modulus. If A is congruent to B mod M, then M divides into A minus B. So it might be confusing to look at this and go, it might be confusing to look at this and understand what it means, because when you have just symbols and letters, it's hard to understand. So let's go back to that 2 mod 7 and 2 mod, or sorry, 3 mod 2 and 2 mod and 7 mod 2. So we know from the previous slide that 7 mod 2 is we know from the previous slide that 7 mod 2 is equal to 3 mod 2. But even if we didn't have the previous slide, we know that that is true. So we know that 7 is congruent to 3 mod 2. So therefore, we know that 2, which is the number we are dividing, or the modulus, right? We know that the modulus divides into the difference between these two numbers. So it says 7 minus, in this case, it says that 7 minus 3, which is 4, is a multiple of 2, since 2 divides into 4. So that is a lot of words, because it's a bit hard to just explain it without a lot of words. But basically what it's saying is, if you have two numbers which have the same remainder when divided by a number m, then m divides into the difference. The difference is a multiple of those two numbers, of the difference between those two numbers. Okay, so the Grinch wants to throw coal at kids so that everyone gets an even number of coal, or an equal number of coal. There are 17 kids and he has 5 chunks of coal. Represent this situation using the identical to symbol. And just use the equal sign because I don't think you can type the congruent sign, but that's like copy pasting it online. So just it's easier to do the equal symbol. So represent this as a modular, as an equation.
That's actually not a very bad drawing of the Grinch.
Yeah. Yeah, the Grinch does look like an evil frog. Okay, so while you all are technically not incorrect, right? The equations you all wrote are correct. While that's true, that isn't really what I was looking for. But good job for understanding the concept. So basically, I was looking for you all to say that 17 mod 5. Okay, sorry. I was looking for you all. Okay, sorry. It's supposed to be 17 chunks of coal and 17 kids. Chunks of coal and 5 kids. Sorry. Let me just, yeah. Okay, so I was looking for you all to say that 17 mod 5 is congruent to, and then whatever the remainder would have been, right? How much coal the Grinch would have left over. So 17 mod 5 would be equal to 2, right? So 17 should be congruent to 2 mod 5. So that was more of what I was looking for. However, you all are not incorrect. So like, good job for being able to write a true equation. So yeah. Okay. Okay, so take that equation of 17 is congruent to 2 mod 5 and represent it as using the divides into symbol. So wait, let me just write this out. So remember we said earlier that m divides into a minus b from that original equation. So how would we represent this in terms of this? Okay, yeah. So you all are correct, and yeah, it's fine that you can get the straight line on your computer. By the way to type it would be if you're on a computer, it should be above the enter sign. So it should just be shift and then the symbol above the enter sign. But if you do not have that, that's also fine. So it would be represented as 5 divides into the difference between 17 and 2. So 5 divides into 17 minus 2, and that is equal to, that means that 5 divides into 15, which we do know is true. So yeah. Okay, so good job. Okay, so so if we know that a number mod and other number is equal to, so if we know a mod b is equal to c, then we know that there is a number for which if we multiply the modulus and add it to whatever the remainder is, we will get that original number. So think about a division equation, right? If you divide a by b and you get a remainder of c, then you can, if we think about a division equation, if a divided by b is equal to something remainder c, right? Then we know that there exists some number by which we can multiply this, right? There's some number k by which we can multiply b by. So k multiplied by b, and then we can add that remainder to it in order to get a. So that is basically what this slide is saying. So k times b. So there's some just random constant k, some random integer k, that k times the modulus. So the modulus here plus the remainder is equal to that original number. So yeah. So for example, in 34 mod 10 is equal to 4, we know that there is some number by which we can multiply 10 by and add to 4 in order to get 34. And just from looking at this, we know that the number has to be 3 because 30 plus 4 is equal to 34. So that k would be 3. So that's just something to note about modulus. So another thing you might be wondering is how to do negative numbers in modular arithmetic. Like how would we like find, for example, negative 52 mod 5? So if we use that original concept we had on the previous slide, we would know that we would do we would have a number by which we can multiply that modulus by and add to the remainder in order to get in order to get that original number. So there's a number by which we can multiply 5 by and add some number r to in order to get negative 52. So the number that we have, like that remainder, will always be positive and between 0 and the number we are dividing by. And it's between 0 and the modulus, but it cannot be the modulus, but it can be 0. So we know that to be true. So that means there's a number that is between 0 and 5, not including 5, where we can add to 5 multiplied by some other number and get negative 52. So that would so that might not make a lot of sense, but we can multiply some, but basically if we multiply 5 by negative 11, we'll get negative 55, and we can add a number to negative 55 that is between 0 and 5 and get negative 52 from that. So that number would be equal to the would be equal to the remainder, right? So that number in this case is 3, because we can add 3 to negative 11 times 5 and get negative 52. Therefore, 3 has to be the answer here. So does that make sense? Because it's a bit harder to understand negative numbers because just the sign change makes it a bit confusing. Because if we had this in positive numbers, you would think 2, but then you'd think, oh, it has to be negative 2 because you're just used to thinking like in positive numbers, but it wouldn't be negative 2, it would have to be positive 3. So does that make sense? Just type yes in the chat if it does. Otherwise, you can private message me any questions you have. iPad, you said no. So do you have, like, what questions do you have? Do you have questions? Okay, so do you just want me to re-explain it? Okay, so we have a negative number, right? So in this case, it's negative 52, but we could take a smaller example. So let's just take negative 8, right? Because it's easier to work with, well, technically it's a larger number, but a number that's closer to 0, right? So let's do negative 8 mod 5. So there is a number by which there is a number between 0 and 5. So that is either 0, 1, 2, 3, or 4 that we can add to some multiple of 5 such that we get negative 8, right? So in this case, we could see that the multiple of 5 that is the greatest multiple of 5 that is below -8 is equal to -10, right? So we know that if we were to do negative, we know that -10 is less than -8. So what we would have to do is find the remainder, which would have to be one of these 5 numbers, and have that remainder be something we can add to this multiple of 5 such that we get the original number, which is -8 in this case. So if we had to add a number to -10 to get -8, that would have to be 2. So 2 is 0, 1, 2, 3, or 4. It is one of these 5 numbers. So that means that 2 is the remainder, that 2 is the answer in the case of -8 mod 5. However, oftentimes it's easy to have the misconception of if we were doing 8 mod 5, we would get 3. Therefore, -3 would be the answer in this case. That's not how it works. But -3 mod 5 would be equal to -8 mod 5. Does that make sense? Okay. Okay, so another example of this would be 17 mod -2. So we are working with negative numbers here. However, it's slightly different. So earlier we had the positive number was the modulus and the negative number was the number that we're dividing, right? However, in this case, now that we have a negative number, right? So now that we have a negative number, it is slightly different. So the remainder we have will always have to be positive when we're solving for this. That is always going to be true. It'll either be positive or 0. So that means that instead of being between 0 and -2, it would have to be between 0 and 2 in this case, not including 2, because we can't get a remainder of 2 that we can't get a remainder of 2 when dividing by -2. So that means it has to either be 0 or 1 as the remainder in this case. So we have 17 mod -2. So there is a number by which we would multiply. So there is a number by which we can multiply -2 to So the greatest multiple of -2 that is below 17 is 16, right? Because that is -2 multiplied by -8. So the number we would add to that to get 17 is 1. And that number is between 0 and the absolute value, or the positive, whatever -2 would be without the sign, right? So the absolute value of -2, right? So it's between those two values of 0 and the absolute value of -2. So that means that 1 is the answer. So someone asked in the chat, can the answer be a negative number? If you're trying to say that like 17 is like 17 mod -2 is congruent to -1 mod -2, that would be correct. However, when they're looking for an answer like this, they are looking for a positive answer. So a number that is between 0 and the absolute value of whatever that modulus is. But it cannot be the absolute value of the modulus. It has to be less than that, right? So yeah, so it's not going to be negative in any case where it's asking you a question in the form like, what is 17 mod -2? It's not going to be negative in that case. However, they could ask you, someone like on a question, you could be asked, what is congruent, like write a modulo that is congruent to 17 mod -2. And you would be correct in saying -1 mod -2. So yeah. Do you all have any questions about that one? Because that is a bit confusing. If you do not have questions, say yes. Otherwise, say no, and you can private message me a question. Okay. Okay, so what is negative 13 mod 5 in the chat? Okay, yeah, I am seeing a couple of answers. It is 2. So we would try to find the greatest multiple of 5 that is less than negative 13, and that would be negative 15. The number we would have to add to negative 15 in order to get negative 13 is 2. So therefore, negative 13 mod 5 is 2. What is 22 mod, or negative 32 mod 6? Okay, yeah, you all are saying 4. That is correct. Again, we would try to find the multiple of 6, the greatest multiple of 6 that is less than negative 32, and that number is negative 36. And we would have to add 4 to negative 36 in order to get negative 32. So the answer is 4. What is negative 43 mod 5? Okay, yes, you all are correct again. It is 2 for this one. Remember, we would just find the multiple of 5, the greatest multiple of 5 that's less than negative 43, and that's negative 45. And we just have to add 2 to that in order to get negative 43. What is 7 mod negative 6? What is 7 mod negative 6? Sorry, yeah. Okay, yeah, I am getting a lot of the correct answer. It is 1. The greatest multiple of negative, okay. Yeah, no, this should read 1, not negative 5. But yeah, it is 1. So 7 mod negative 6, you would find the greatest multiple of negative 6 that is less than 7, and that would be 6. And the number we'd add to that in order to get 7 is 1. So that would mean the answer is 1. What is 54 mod negative 7? Okay, yeah, you all are correct. It is 5. So 54 mod negative 7, we would find the multiple of negative 7, the greatest multiple of negative 7 that is greater than, that is less than 54, and that would be 49. And the number we would have to add to 49 in order to get 54 is equal to 5. The answer is incorrect here, though. So let me just change that. Okay, and then last one. What is negative 5 mod negative 2? Okay, yeah, a couple of you have gotten the right answer. It is 1. So remember, we would have to find the greatest multiple of negative 2 that is less than negative 5. That would be negative 6, right? Since we multiply negative 2 by 3 to get negative 6. And the number we'd have to add to negative 6 in order to get negative 5 is 1. So that would mean the answer is 1. Okay. So complex modular arithmetic. So this part is a bit difficult to understand, and we might not have enough time to get into it. But basically, if you are adding two numbers together, A and B, and you find the modulus of the sum, right? That is equal to finding the modulus of the sum of the modulus, or sorry, not the modulus of, okay. So, sorry, we don't have a blue kit for today, but next class we will, I promise. Okay, but a mod, okay, so if we have two numbers, let's just make them up, 5 and 12, right? And then mod 4, okay? Or mod, I don't know, mod 7. Okay, so if we have 5 mod 7 and 12 mod 7, right, we could add them to, sorry, we do not have a Kahoot either. Well, actually we do, but okay, we could do the Kahoot. Okay, yeah, okay. Rather than get into the complex modular arithmetic, which you all can review on the slides and just private, or no, you could email us any questions you have about that. Right, you could do that, or you could just you could do that. Okay, sorry, but we will post the slides. So okay, sorry, I do not want to log in. Yeah, so we can do the Kahoot. Yeah. Okay. Okay, give me a minute. Okay. Okay. We do have a Kahoot, and this is it. I am gonna close my other tabs because my computer is really slow, in case you didn't notice. But yeah. So if it ever loads, we will play a Kahoot.
I cannot play Kahoot.
Oh, are you on a computer or an iPad?
I'm on an iPad.
Oh, I think you can play it from the browser in an iPad. Otherwise, the questions will still be here, so you could solve them and get some practice. Or you could just get another device if that is possible for you right now. Like just ask for your parents' phone or use your own phone. Yeah. Okay, the code. I will put the link in the chat. You all have very unique characters. Yeah. Okay, I will start. What is 35 mod 6? Okay, yeah, the answer is 5. We would find the greatest multiple of 6, that's less than 35, and that's 30, and the difference between 35 and 30 is 5. So good job to Shade. What is 5 mod 8? Remember, you all did mess up a question like this earlier, so make sure to think of it like I told you all to. Okay, yeah, the correct answer is 5. Remember, the first number is the number we are dividing, the second number is not. So good job to Shade again. What is 19 mod 8? Okay, yes, the answer is 3. The greatest multiple of 8 that is less than 19 is 16. 19 minus 16 is 3. Okay, yeah, the correct answer is 5. The greatest multiple of 6 that's less than -1 is -6. The difference between -6 and -1 is 5. So the correct answer is 5. What is -8 mod 20? Okay, yeah, the greatest multiple of 20 that's less than -8 is -20. The difference between -20 and -8 is 12. So the correct answer is 12. Which of the following is the modulus shown on the clock? So on this specific clock. It is 8, not 7, because remember on a normal clock, we have 12 sections. On this clock, we have 8 sections, despite it being numbered 0 through 7. So remember for mod 8, you can have any answers between 0 and less than 8. Okay, which of the following modulus does the clock below show? Okay, yeah, the answer is 12 because there are 12 sections, and also because it's every number between 0 and less than 12, or every integer between 0 and less than 12. Okay. What is -4 times -4 mod 9? Okay, yeah, the answer is 7 because -4 times -4 is 16, and 16 mod 9 is just 7. If it's 1 o'clock and 55 hours pass, what time will the hour hand shown up? Remember, it says hours, not minutes. Okay, yeah, the correct answer is 8 because 55 mod 12 is 7, and 7 plus 1 is just 8. If the day of the week is Thursday and 278 days pass, what day of the week will it be then? Okay, yeah, the correct answer is Tuesday because 278 divided by 7 is equal to 5. Sorry, 278 mod 7 is equal to 5, and 5 plus Thursday is just Tuesday. Okay. If the day of the week is Monday and 27 days pass, what day of the week is it now? Yeah, it's Sunday because 27 mod 7 is equal to 6. And yeah. Okay, modular arithmetic. So in first place is Shade. I do not know who that is. And second place, Daniel, and third place, E. So good job to everybody. Yeah, okay, yeah. Good job to everybody who is on the podium. And yeah, yes, you can leave now. Have a great day and or have a great week.